Hello, James Sylvester from JPS Reliability. Today we're going to go over a really cool case study we did lately on vibration dynamic absorbers. For people who don't know me, I'm James Sylvester, Director of JPS Reliability. I'm a fitter turner by trade. Left school 1990, went straight into an apprenticeship, fit and turning. Did that for over 10 years, and then while I was at a chemical plant, I fell into condition monitoring. So I've been lucky enough to go to Australia for a few years, and I'm doing it now 25 years. So I'm a very practical based engineer, and we've actually written 2 books. A little bit about JPS Reliability. Say we're a team now of 7. So we're an independent specialist team. We've got decades of experience between us all. And what we pride ourselves on is using common sense, which isn't much common nowadays, in applying condition monitoring and reliability together to make sure that sites clients get the best out of their money on their assets and their system that it runs best for them. As I say, we're totally independent. We do global support, and as you can see from the map over here, these locations are all the locations that we've actually sold our books to. Just very briefly cover our 2 books. Now, both our books are available to purchase off our website. Click and buy and it'll be delivered to you. The first one here, Enhancing System Reliability Through Vibration Technology. That one was basically 20 years of my little black books and notes I used to write down things I found interesting, and it's a good way for me to learn. I basically converted into this book. So this book is like a condition monitoring Bible from a practical person for practical people, covering vibration analysis, condition monitoring and reliability. Now in the back of that book I did a few case studies to try and help explain things better, because when you get a real life case study, people understand it more. And that's what led to this book. So this book is a JPS Reliability Book of Gold, and it is written with myself and James Pierce, the other director of JPS. And you can see we have over 100 case studies in there where we have the vibration, the strip down, the inspection and the follow-up. This is to cover like the body of knowledge. So you can do your ISO course, you learn the theory. If you're not lucky enough like we are to go around so many different places, different environments and industries, you don't learn as much. So this is to help people learn. So briefly, today's case study is on vibration dynamic absorbers. Now, they're mechanical systems designed to absorb vibration. They're not new. They've been around for many years, and you often see them like on telegraph poles on electrical power cables as they go along. When you get to the pillar, you get these little T pieces. If you look up there under there, now they vibrate at the resonant frequency of the cable. So when they get the aero flutter and the air makes the cables move, these bits absorb and take the energy. Now, VDAs are often seen as a sticky plaster, a band-aid, but what we try to do is we try and look at the whole system. So we go there, we do investigation with many technologies, many different condition monitoring technologies to work out what the root cause is, what the frequency is, and work out how we can stop the asset failing. Because the cost to build, say, a brand new pumping station could run into millions and millions, and the cost for maintenance while it keeps breaking is a lot of money. So these are a very good solution to prevent vibration, which can cause secondary damage to other pumps and motors. Here is the pump station in question. So on this particular site, you see these pumps, there's scaffolding around there so we can get access to, but they're deep well pumps. So they're down in the dry well, and there's a structural resonance at 11.3 hertz, just what it is. And they're on a variable speed drive, unfortunately. And when they run them for process efficiency, electrical efficiency, save money, as soon as they hit 680 RPM, they start to rock. And what they have been finding is this sustained structural vibration is causing the whole system to vibrate. And then you get standby motors, which don't run for a while. Inside, they'll be vibrating at this frequency. And now what that's going to do is impact on your bearing, the lube film thickness, and then what do we get from there? force Spinelling. So the best cost-effective solution for this station is to make these VDAs. Yes, as a reliability engineer, you might say, right, let's knock it down, rebuild all the pipework, redesign everything, and you're talking millions and millions and millions of pounds and disruption. Whereas we can design these absorbers as a sacrificial item and the vibration can stop. So the next picture here is, well, this picture is a video. So this is the absorbers fitted. And you can see them up there. And what I'll do now is I will play the video there. So if you watch this video, you can see them shaking and stopping and shaking and stopping like a beat frequency. What's pretty cool about the VDA is you need to know your primary mass. You need to know the excitation frequency, your absorber mass, and your absorber stiffness. But bear in mind, you're talking, you have certain materials within your steel, certain carbon content. At a certain frequency, all those molecules in the steel will start to move. If you think along the lines of the opera singer, where you have a glass and she sings, and the frequency of her tone of her voice as singing causes the glass to shake and explode. Same sort of thing here. We're designing these absorbers so at a set frequency they're excited, the molecules are self-excited and they move, and it takes away the energy. These we usually have like a slot there, so we work out the hertz and we design it so a certain movement is a certain frequency, a certain speed, so you can actually do it so we can have different frequencies. So as speed goes through a range, it can activate certain absorbers, because you've got to remember these absorbers are tuned for one frequency. So as you can see there, it's moving around a little bit like that. And what's really good is, probably a first in the world, I don't know, but to actually record vibration dynamic absorbers with motion amplification. So this video here is a standard video which you see with your eyes, and this video here is amplified, and you can see by the length of the vectors at the top, a lot more movement than the bottom. So as we measure with vibration analysis, we know it's rocking a lot more. And when we went around the side there and actually put your hand on the motors, because they're large motors, you could feel that structural energy which wants to break out and be absorbed, and that's causing this motor to rock like that. Now that's just the MA video, and you can see where we're getting up to 42 millimeters per second peak here. So the motor's rocking with a high vector there. But also look at the side here, the handrail. You can see the handrail there and here. The handrail's moving. So you can imagine that massive pump on that huge outlet pipe is trying to move, and it's got all this energy, it wants to let it go, and it can't, and it's stiff and it's rocking. All that energy is going for the pipe work, through the structure, the handrails are moving slightly. Now you can imagine the standby pump either side, the rotors inside those are going to be doing this. And that's what gives you your force Spinelling and your low reliability. Now this next one here, you can see at the top now, so we've got our absorbers, we've now tuned them in here. And we've gone down from, what, 42 plus, down to 1.5. So if you watch the video now, what's pretty cool is these vectors, well, it's actually larger vector now at the pump, but the vector here, here, and here are the same vector, so it's pretty still, stationary. But look at the top. Look how the absorbers are whipping in and counteracting each other. So now that structural resonance energy is now going up there and being absorbed and let go as heat. So down at the point here, the fix here, that's where the absorbers are moving. Now, depending on how thick the cross-sectional area of the absorber will dictate how long it lasts before they break. We do have the wire strops on them coming down to help any droppages, but what we have found, in we're doing these absorbers now for like 8 years, 8-9 years, we've been doing it and changing the design and tweaking little things, that as soon as they fracture across the point of twist, it just stops moving. It doesn't fly off, it just stops moving because you change the whole physics of the steel and the dynamics. So we are very, very pleased with this, and now you could go up to that pump, touch the motor, and you can't feel that energy, that force which wants to go, has been absorbed. So you can see going forward, the costs to replace these absorbers now compared to the cost, the downtime, the health and safety risk of actually taking these fuse pumps out has all been reduced now. And yeah, we were very, very pleased with this outcome. And usually end up any sort of presentation or case study with our pearls of wisdoms. These are in our books, but these are things which people should keep in mind when they're doing condition monitoring reliability. Like wall chart analysts who take it 1 times RPM is not always vibration. The 2 I feel most important is the most important part of any program is the person performing the data collection and analysis. Don't send data dogs. The second most important part of any program is the training and mentoring given. You've got to support people, share knowledge so they can learn and learn more. Anyway, I've talked too much now, but yeah, I hope you enjoyed that case study. And if you do have any pump issues, you need any help, you know who to call, the JPS team. Take care. Bye bye.